We've got a solution that contains 100 grams of water and 25 grams of ethanol. We need to know what are the mole fractions of water and ethanol, and what is the vapor pressure of the solution at 25 degrees Celsius. We are told that the vapor pressure of water is 23.8 torr, and that the vapor pressure of ethanol is 58.7 torr. Since we are given two vapor pressures, this would fall into the category of the second type. I've got two volatile substances. So my equation is going to be that the total pressure is equal to the mole fraction of water times the vapor pressure of water plus the mole fraction of ethanol times the vapor pressure of ethanol. So I've got some calculating to do. I've got to find the mole fractions for each, which means first I got to figure out how many moles of each thing I have. So 100.0 grams of water, 18.02 grams in every mole. 100 divided by 18.02 is 5.549 moles of water For the ethanol, I have 25.00 grams of ethanol and 46.08 grams of ethanol in 1 mole. 25 divided by 46.08, 0.5425. Moles of ethanol. To find the mole fraction of water, I need the moles of water, 5.549. Divide by the total number, 5.549 plus 0.5425 would be 6.092. Which would be 0.9109 as the mole fraction of water. The mole fraction of ethanol would be 1 minus 0.9109, which would be 0.0891. I could have found the mole fraction of ethanol by taking that 0.5425, dividing it by 6.092. However, since there are only 2 components in that solution, if one of the components makes up 91.09%, the other one would make up the remainder, the 8.91%. So logically speaking, I could do subtraction, which is a lot faster than the division. So now I got to put all this together. My total pressure is equal to the mole fraction of water, 0.9109, times its vapor pressure, 23.8 torr, plus 0.0891, the mole fraction of ethanol, times its vapor pressure, 58.7. When you're doing this calculation, sig figs become vitally important because you are going to do a multiplication, which is going to require a round. And then you're doing an addition, which is going to require an additional round. Remember, anytime you switch between multiplying and dividing and adding and subtracting, you have to make your adjustments in between. You can't just carry out all the decimal places because that's actually overestimation. So 0.9109 times 23.8 to 3 significant figures is 21.7 torr. 0.0891 times 58.7 is 5.23 torr. Put those together, rounding to 1 decimal place because that is all that is possible out of the first. We get 26.9 torr. So, as I mentioned before, the value that we get squeezes in between the two vapor pressures of the two components. Since water made up the majority of the solution by quite a significant portion, we can see that it is definitely shaded toward the water as opposed to toward the ethanol. So the vapor pressure of ethanol gets dropped considerably because of the increase of attraction to the water molecules. And the vapor pressure of the water really doesn't change that significantly. Now, for Raoult's law kinds of problems, these are about as complicated as they get when you have multiple volatile solutes. Any questions about this one? If you can do this one, you can pretty much do any Raoult's law problem. Like I said, this is about as complicated as they get.